Okay, so I went to the beach for this one to grab some coral, and here I am crushing up the coral. So the reason I'm doing that is because it's too difficult to get limestone in Brisbane. They kind of mined it all out of Ipswich quite a while ago. And then because it's so important, they ended up just dredging coral out of out of Brisbane River and the Moreton Bay kind of. And so couldn't get my hands on limestone locally, so just grabbed a few pieces of coral. Now, hopefully you'll get to do this one because it's quite important. Number one, it's a calcium cycle, so the more cycles you sort of get a handle on, the better you understand the environment. But this one also directly links in with the carbon dioxide cycle. They interlink, so carbon dioxide's going in and out as well. And so that's critical for pretty much every syllabus. They throw the carbon dioxide cycle in there and greenhouse gases, etc. It's also important for chemistry because we use the hydrated lime, that's actually called lime water, the calcium hydroxide. And when you bubble carbon dioxide through it, the calcium carbonate precipitates. So, and on top of that, cement's also the second most consumed substance only to water, all right, by volume. And so that's from basically this cycle, so calcium oxide, 62%. All right, and just a few interesting points besides that. They're still working out what the chemistry is. So chemistry often works by experimental evidence and then the theory comes later. They're still trying to work out the full chemistry of it all. And the other major point is the English again. All right, so forget the word lime, kind of means nothing. All right. Limestone is calcium carbonate, but it's also called agricultural lime. And then I would say calcium oxide is the cement, quicklime or burnt lime. And so you put heat into it and carbon dioxide comes off. And then when you add cement to aggregate to make cement, so there's the cement and you add gravel and sand to make concrete, so cement, and that's the difference between the two, then you get these chemical reactions, and you get that happening. Heat, it gets hot, and the water forms hydrogen bonding and bonding between the aggregate and the cement. But if you just put quicklime by itself in water, that is lime water. So hydrated lime, slake lime, all other words for it. And what's good about filtered calcium hydroxide is a little bit of carbon dioxide in it and calcium carbonate precipitates out, and then you get the whole cycle again. Okay, so it's kind of really important for all the sciences, including chemistry. So the other thing that I didn't do is finish this off. So I didn't get the I basically crushed it up and then put it in a boiling tube and heated it up. But when you heat up copper carbonate, and it turns to copper oxide, this is calcium carbonate to calcium oxide, you get like bubbles of gas come off. And I don't notice any bubbles. And so I think that's an issue. And then when I added water to it, it also didn't go up in temperature, which kind of shows that I didn't heat off the calcium carbonate. And I still filtered it off to see whether something would happen, and I bubbled gas through it. I just blew through it, and it didn't go a milky colour. So I'm just checking them both. They definitely have calcium carbonate in them. They react with acid. So I tried a piece of limestone. I wanted it to be just completely local, but I just thought, okay, let's just see what this happens. I'll powder up more. And then I also burnt it for a lot longer. So that's going in, how many minutes that's like, that's a good 5 minutes, I would say, almost 5 minutes now. Now, I often I say I'm impatient, but the reality is I need to be a little bit impatient because if students are going to get this done in half an hour, then we've got to be quick. And the big issue with this is it has to cool down, so that's probably the biggest bottleneck. But because this one didn't work that great either, you can see it went up to 20, from 23 it went up about a degree. It shows that it was partially working, and then I still tried to filter it out and blow it through, and it still didn't work. So what we need to do is measure the mass before and after of the calcium carbonate, and heat it, unfortunately, a lot longer, so 1,000 degrees, possibly even up for an hour if you've got time for that, and then continue the next day. And you need to have a significant decrease in weight or see the bubbles of carbon dioxide come off. And then, so that would be the cement. And then when you make the lime water, you need to measure a significant increase in temperature to also prove, to doubly prove that the reactions worked. Okay, so a bit of problem solving yourselves. I have had this work with calcium carbonate straight out of the bottle, but I didn't want to do that. I want it to be legit, so I went to coral because that's legit for Brisbane anyway. Okay, hope you enjoyed.